Problem 16 is another scientific notation problem, and in this problem we're simply asked to take this number, 5.68 times 10 to the negative fourth power, and put it into what we call standard notation, which means we want to get rid of the times 10 to the fourth power and actually put it into what this number would actually be. Now, with scientific notation, when you have a negative exponent, it means it's a very small number. It doesn't mean it's a negative number. It just means that we've moved the decimal point in a way to take a small number and make it into just a single decimal point, one number before the decimal point number. And so what that means is that we took the decimal point from its original point, which was further over to the left, and moved it to the right 4 places. And so if we look at some of the numbers that are given, if we actually do that, if we take this spot and move the decimal point 4 places to the right, you'll see that the number just gets bigger in this case. And so in the case of this one, and really using your calculator in this case doesn't help. We could try that. Done that in some previous problems where I just took the number and put it in my calculator, 5.68 times 10 to the minus fourth power. And you can see that that doesn't help at all. I get this, again, basically scientific notation. The E is a shortcut way that a calculator represents that times 10. So if you see that E in your calculator, it's putting it in scientific notation. So that didn't help at all. So what I have to really understand is what's happening here. Negative fourth power, a very small number, is being made into a single digit or single number in front of the decimal point. And so I could do this with this one also and see that it's just going to 1, 2, 3, 4. If I move the decimal point 4 places, it's just going to make it bigger. These numbers get bigger. So these two answers could not be true. Now with the next one is the first one that looks like if I take the decimal point and move it 4 places to the right, 1, 2, 3, 4, I'm going to get something close. The decimal point is right there. That's 0.568. 0.568 times 10 to the minus fourth, so that's not quite right. But if I go to the very last one, and again, to the minus fourth, makes a small number, 1, 2, 3, 4 places to the right, and now I get 5.68. I moved it 4 places to the right. In other words, it was a really small number, and so again, the negative power does not mean it's a negative number. It means it's a very small number, and that moves the decimal point 4 places to the right. And now I have, in scientific notation, you always have one number in front of the decimal point, any of the remaining digits following, and how far you move the decimal point, either to the left to make it bigger, positive, or to the right from a smaller number to this form. So this is actually the correct answer in scientific notation for 0.000568. Small number made into a scientific notation, one number in front of the decimal point, and then the exponent telling you how far we moved the decimal point. Or in some cases you can think of it as how many zeros we placed, including the first number, in front of the decimal point. This one took 4. This one, if we had wanted to write it in scientific notation, we would have had to move it 5 places, 1, 2, 3, 4, 5. So I could have actually written this one in scientific notation by writing 5.68 times 10 to the minus 5. And in fact, I could go back to this problem, B and A, and write those in scientific notation. 5.68 times 10 to the 1, 2, 3, fourth power, because those are big numbers. And this one is 5.68 times 10 to the 1, 2, 3, 4, 5, 6th power. Because that's how far I would have to move the decimal point to make each of those work. 1, 2, 3, 4, 5, 6 numbers over before I get to the first number. 1, 2, 3, 4 numbers over before I get to the first number. Going the other way, 1, 2, 3, 4, 5 numbers before the decimal point. So that's why it's to the negative fifth power. And then 1, 2, 3, 4 numbers over before the decimal point. So negative fourth power. And the trick with this is knowing which way to go. Negative exponents are from small numbers. Positive exponents are from large numbers. And these are all representations of writing scientific notation either from standard form to scientific notation, or we could go the other way with it.